Okay, this morning we are going to look at dividing polynomials. And so we're going to look at two different strategies for dividing polynomials. We're going to look at when we're dividing by a monomial and how when we divide by a monomial, we're actually going to just set them up as individual fractions and divide each term. And then we're going to talk about what happens when it's a binomial. So let's start with a polynomial divided by a monomial. So we've got a trinomial here, and we notice that we're just dividing by a single monomial. So we could write that as a fraction. So 3x squared plus x minus 6 all over 3x. And so when we have it in fraction form, we know that we can actually take our divisor and distribute it to each term in the numerator. So we can turn this into 3x squared over 3x plus x over 3x minus 6 over 3x. And then we're going to go ahead and simplify each fraction individually. So if I'm looking at my first fraction, my 3's cancel, as does one of my x's. So I would be left with just x. My second fraction, my x's cancel out, so I'm left with 1/3. That's a positive term. And then finally, my 6 and my 3 are both divisible by 3. So I'm left with 2 over x, and because it's negative, we have subtraction here. So we would have x plus 1/3 minus 2 over x. Okay, now let's go ahead and look at what happens when we have a trinomial divided by a binomial. This is a little more complicated because we couldn't put it in the fraction form like we were just talking about. Because if I did that, notice that that wouldn't really help me. I wouldn't be able to cancel out any common factors because of the addition. So I'm going to have to come up with a different strategy for simplifying this for doing the division, and we're actually going to use just traditional long division. All of the principles are the same as when we learned how to do long division back in not third grade, probably fourth grade. But we just are dealing with variables. So just like when we learned how to do like a 2-digit number divided into a 3-digit number, we were focusing on that first digit. And so we're going to do the same thing here. We're going to focus on our first term, and we're going to think m times what gives us m squared, or how many times does m go into m squared? Well, m times m is m squared. So m goes into m squared m times. But because this is a binomial, I'm putting it over the second term. Now, just like traditional long division, I'm going to distribute that m. So m times 1 is positive 1m. M times m is positive m squared. And then I'm going to subtract. So 4m minus 1m is 3m. M squared minus m squared goes away. I'm going to bring down my plus 3. And now I'm doing the same thing. How many times does m go into positive 3? Or what times m would give me 3m? So m times 3. So I'm going to have a positive 3. 3 times 1 is 3. 3 times m is 3m. And when we subtract those, we get 0. So our answer to this division problem is m plus 3. So here's our next problem. First thing we always want to do is if our polynomial is not in standard form, we need to rewrite it in standard form. We always need to have, the terms in degree order. So I'm going to rewrite this. And now I'm going to go ahead and set up my long division. So how many times does y go into y squared? It goes in y times. Y times negative 3 is negative 3y. Y times y is y squared. Remember, we're subtracting here, so this gets a little bit tricky. So it's negative 7 minus negative. So that's like plus 3y. So we end up with a negative 4y here. So we just want to be really careful with our signs. That can get tricky. And y squared minus y squared is going to cancel out. we're going to bring down our plus 2. Okay, so now y goes into negative 4. So that would be negative 4 times, right? Because I have a positive y, but I want to get a negative 4y, so I have to have a negative 4. So negative 4 times negative 3 is positive 12. Negative 4 times y is negative 4y. And don't forget we're subtracting. So 2 minus 12 would give us a remainder of negative 10. Now, we can't continue dividing, so this is going to be turned into its fraction form. Just like we could do when we were doing long division, right? If we had a problem like 4 divided by 3 and it only went in one time and we couldn't continue dividing, we could do a decimal, but we also learned that we could take this and we could say our answer is 1 1/3. We took our remainder and we put it over our dividend. We're going to do the same strategy here. So our answer is y minus 4, and then we're going to take our remainder, negative 10, and we're going to put our remainder over our dividend, y minus 3. And so our final answer is y minus 4 minus 10 over y minus 3. So we just turned the remainder into a fraction. Go ahead and try another one. So this time it's interesting. It's a binomial, but we need to actually write it as a trinomial in our division because we need to show that we do not have any q terms. Otherwise, when we're dividing, we're going to kind of get stuck and we're going to not be sure what we're doing. So we have to put this in there as like a placeholder, right? Just like we would put 0 placeholders in when we're doing long division if we didn't have any numbers in, the tens place. So we would want to do the same thing here. So q goes into 3q squared, 3q times. 3q times negative 2 is negative 6q. 3q times q is 3q squared. We're subtracting. So remember, minus a negative becomes a positive 6q. Our 3q squared cancel out. We're going to bring down our negative 8. So q goes into positive 6 times. Positive 6 times negative 2 is negative 12. 6 times q is 6q. And don't forget, again, we're subtracting. So when we subtract here, 8 minus negative 12, that becomes a positive 12. So we get positive 4 as our remainder. So our answer, 3q plus 6 plus, because this is a positive term, the 4 goes in the numerator, and the q minus 2 goes in the denominator. Okay, so just be really careful with turning those remainders into fractions.